Hey, welcome back. In this video, we're going to display the health value on the screen, but to do that, we first need to have a discussion about strings. We'll talk about C-style strings, as well as the standard library string type. Let's get started. Now this is a C-style string. That keyword char, sometimes called char, is the keyword for the character type. You'll notice that sword is an array of this type. Now on the right side of the assignment operator is the string sword in double quotes. This is known as a string literal, and it can be used to populate an array of chars. We don't need to place an integer in the brackets because the compiler is capable of deducing the size of this array based on the length of this string literal. Now what you don't see, and what's placed in the array at the end, is something called the null character. We say that C-style strings are null terminated, as they always contain this null character at the end. So here is the array, depicted in boxes, and in each box is a character. Character literals are surrounded by single quotes, not to be confused with string literals. And the very last character here is the null character. Much like the newline character, it looks like two characters, but it's actually a single character, which we call the null character. C-style strings are what we had to use in the C language before C++ came around. And they're still used in the C++ language, but as a programmer, you're a lot more capable if you're familiar with the string class, which exists in the C++ standard library. To use the string class, you include the header file string. Notice the pointy brackets. Remember, standard library header files are special. They get pointy brackets. Now, the standard string is a class in the standard library that contains a C-style string under the hood. That's where it stores the actual string, but it's also much more versatile and contains functions. This is how we declare a new variable of the string type. Notice the string keyword is prefixed by std and the scope resolution operator. This std is the name of a namespace, which is a space which contains code, functions, and variables, which can be accessed by using the name of the namespace along with the scope resolution operator. Here we're declaring a string called damage and initializing it with a string literal. So deep under the hood of the damage string instance, there's a C-style string that contains the characters that spell damage. But the string type has special abilities, like the append function. Notice we're taking the damage variable and calling append, passing in another string literal. This function will take that string literal and stick it at the end of the string, so now the string contains those extra characters passed in. Now what if we want to append a number instead of a string? Well, the standard library contains a function called toString, which can take a number and it returns a standard string. Now, the C-style character array contained within that string will have the characters equivalent to the number you passed in. So we'll have a string with the characters 1, 2 in this case. Then calling append with that value will result in a string that contains the string equivalent of that number appended at the end. Now let's say we have a float and we pass that into toString, which we then pass into append. ToString will return a string object that contains the string equivalent of that number, but because this is a float, we have lots of digits. So our damage variable in this case may be more digits than we care to store. But there exists yet another version of the append function which has multiple parameters. The second parameter is an integer designating the starting point of the string we're passing in to append, and the third parameter is the number of characters we'd like to keep. So if we choose 5 here, then we're going to append 12.45, as the decimal point counts as a character. So say we have a standard string and we'd like to display it on the screen. Well, Raylib has a drawText function, but this function requires a C-style string. That's the first parameter. The second parameter is the X position, the third is the Y position, the fourth is the font size, and the fifth is the color. Now we want to work with standard strings in order to manipulate them with the functions that we saw in the previous slides. So how can we pass in a standard string to the drawText function when drawText requires a C-style string? Well, the standard string type has a pretty handy function. It's C_str, but I refer to it as C_string. And it does exactly what you think. It returns a C-style string. So now that we've seen these handy functions, let's set ourselves up so we can draw the health to the screen. So here in the main function, at the top, we're going to include the string header file. So now we can use the standard string. Now let's scroll down into the while loop. I'd like to go down to the point just after we've drawn the props. Here is where I'd like to draw the character's health, but I'd like to make an if-else statement that checks to see if the character's alive, because if the character's not alive, I'd like to display game over instead. So here's how we're going to set it up. I'm going to say if not knight.getAlive. So if the character's alive variable is false, we'll make it into this if statement, and we'll also have the else case. So the if is the character is not alive case, and the else is the character is alive case. Now, if the character's not alive, we're simply going to call drawText, and for the string literal, we'll pass in game over. For posX, I'll use 55.f, for posY, I'll use 45.f, and for font size, I'll use 40, and color will be red. Now, if the character's not alive, then we don't need to do anything else that comes after this code in the while loop. In other words, we'd like to cut to the end of this iteration of the while loop and start the next one. You can do this using the continue keyword. If you use the continue keyword inside of a loop, once the flow of execution reaches the continue, the rest of the loop body is ignored and the next iteration of the loop will start. Now, before we hit the continue, we should call end drawing so the window is cleared appropriately. So this takes care of the case when the character is no longer alive. But what about the else case when the character is still alive? This is where we'd like to draw the character's health. So this will be your challenge. In the else case for the if statement, you're going to draw the character's health to 2 digits. You'll first create a standard string called knight's health, initialized with the string literal health with a colon and a space at the end. Now you're going to use getHealth along with the standard toString function and the string's append function in order to append to the knight's health string the value of the character's health. You'll then use drawText and pass in the string you created, knight's health, only you'll need to call the CString function since drawText requires a C-style string. For the rest of the parameters of drawText, use the same parameters we used when we called drawText in order to draw game over to the screen. Namely, posX will be 55, posY will be 45, font size will be 40, and color will be red. Pause the video and do this now. Okay, so the first step is to create a standard string. We need to use std with the scope resolution operator, followed by string, and we're going to call this knight's health. Now we can initialize this with a string literal, and we'll use health with a colon and a space at the end. Now we're going to take knight's health and use the append function. And what we want to append is the value of the knight's health, but we need to use the standard toString function. And what we're passing into toString is the value of the knight's health, which we'll get using knight.getHealth. Now the version of the append function we're going to use is the one that takes 3 parameters, allowing us to select part of the string passed in as the first parameter to append. We'll start at the first character and we'll keep 5 characters. That way we'll have 4 digits including a decimal point. Next, we're going to call drawText. Now, the first parameter needs to be a C-string, and we're going to use knight's health, only we have to use the C-string function in order to get a C-string from it. Now, for posX, we'll use 55. For posY, we'll use 45. For font size, we'll use 40. And for color, we'll use red. Okay, we can test this out. Let's go ahead and run this. Okay, so there's our health. And you'll see that we're getting 100.0. That's because we chose to keep 5 characters from this string. And as soon as we go down below 100, then we get 2 digits, a decimal, and 2 more digits. Now, because we're drawing the enemy after we're drawing the text, you can see that the enemy is rendered on top of this text, which actually looks pretty cool. And the final thing we can test is printing game over when health reaches 0. So we can let that happen, and there we go. So in summary, we printed the character's health value to the screen, and that involved the use of strings. So we first had a discussion about C-style strings, and then we learned about the standard string type. We also learned about some special functions like the toString function and the strings append and CString functions. We're almost done with this game. In the next video, we're going to wrap this up by adding multiple enemies to the level. See you soon! Welcome back. In this video, we're going to add a chase radius to the enemy so that the enemy will stop trying to chase the character when it gets close enough. We'll see why in a second. We're then going to add more enemies and store the enemies in an array so that it's easier to update them and manipulate them. So let's first see why we need a chase radius. So here's our enemy, and if I stop running, then you'll see that the enemy starts to glitch out when it gets close, and this is because it's reaching its destination and continuing to move as that toTarget vector is no longer meaningful when the enemy reaches the character. So let's add that radius now. So we're here in enemy.h, and we're going to add a float called radius. Now I'm going to initialize this to a value of 25.f and see how that goes. Now to use this radius, we're going to go to the enemy's tick function, and just after we've assigned a value to velocity, we can check that velocity's length. Remember, velocity at this point is the vector from the enemy to the character, so the length is the distance between them. We can place an if statement and use vector to length passing in velocity. And we can check to see if velocity is less than the radius. Now, if it is, then we don't want any movement, so we can simply set velocity equal to the 0 vector. Let's run this and see how it goes. So here comes the enemy, and if I let the enemy reach the character, now it's no longer glitching out. Looks great. And this is going to be your final challenge. You're going to create an array of enemy pointers called enemies. Create at least one more enemy variable, just like we did with Goblin. Initialize it and make sure you give it a different location than the Goblin, otherwise they'll just be on top of each other. Store the addresses of these enemies in the array using the address of operator. Now for all the actions we perform on the Goblin, instead we're going to loop through the enemies array and perform that action on each enemy. Make it easy on yourself by using a range-based for loop. This involves calling setTarget, passing in the address of the knight. It also involves calling the tick function. And finally, in our if mouse button pressed if statement, where we check collision rex with the Goblin, we're going to loop through the enemies and check collision rex for each enemy. And if the weapon collision rec is overlapping with that enemy, we'll call its setAlive function passing in false. Pause the video and do this now. Okay, so we've got our Goblin. Let's go ahead and create another enemy. I'm going to create an enemy called Slime. And I'll use a vector 2 for its position, and I'll go ahead and set its position at 500.f, 700.f. Hopefully that's not off the map. And while I'm at it, I'd like to set the Goblin's position to something other than 0, 0. It looks kind of weird starting off in the water like that. So let's give the Goblin, say, 800.f, 300.f. Now for the Slime, I'm going to call load texture for the second and third input parameters, and I'll paste in the same thing I loaded for the Goblin, except instead of Goblin idle sprite sheet and Goblin run sprite sheet, I'm going to replace the word Goblin with Slime. And that's because we have sprite sheets in our characters folder for a slime character. Here's my semicolon. And now I have two enemies. I'm now ready to create an array. So this will hold enemy pointers, that's type enemy star, and I'm going to call this enemies. Here's my brackets, and I only have two enemies. Now I could put a 2 in here, but the compiler is perfectly capable of deducing the number of elements in an array when you initialize the array with braces like this. So I can simply put these enemies in the braces as a list, starting with the address of the goblin variable, and then finally the address of the slime variable. And there's my semicolon. So we now have an array of enemies with 2 elements. We now need to call setTarget. So instead of doing this for just the goblin, we're going to use a range-based for loop. We'll say for auto enemy and enemies, and we'll call enemy setTarget. And we'll pass in the address of the night variable. So that takes care of setting the target. We now need to scroll down into the while loop where we're calling the enemy's tick function. Here it is, we're calling tick on goblin. Instead, we're going to loop through the enemies. So we're going to say for auto enemy and enemies, and we're going to call enemy tick. These are pointers, so we're using the arrow operator. We'll call tick and pass in get frame time. And finally, here we're checking to see if the mouse button has been pressed. And then we're checking the collision rex. Here we can do another for loop. So just above the if statement, I'll add a for loop. We'll say auto enemy and enemies. And inside this for loop, I'll place the if statement right here. I'll just format the document with Shift-Alt-F. On Mac, it's Shift-Option-F, and on Linux, it's Control-Shift-I, as we've seen before. And instead of checking collision rex on the goblin, we're going to use the enemy. And since this is a pointer, we're using the arrow operator. And if there is a collision, we want to call setAlive not on the goblin, but on the enemy in the for loop. Now, before we test play this, I'm going to stop drawing the weapon collision rectangle. Remember, we're calling draw rectangle lines here in the character's tick function. I'm going to remove that. And now let's give this a test run. All right, here come the enemies. And they're pretty quick, so if you want them to be slower, you can adjust their speed variable. Let's see if we can destroy them. There we go. We saw that they were doing damage quite quickly, and we've already tested the game over scenario, so this is looking great. Okay, excellent job. We've now created this nice little 2D game, and really there's no limits on what you can do with this. You have the skills to add so many different features to this. There's no shortage of free 2D assets out there that you can use, and you've now learned the fundamentals of the C++ programming language. That's actually a pretty huge feat, so I would like to personally congratulate you for making it to the end of this series. I'd like you to give yourself a big pat on the back because you've come such a long way and you've learned quite a lot. So in summary, we've added multiple enemies to our game, and we've now finished the game. We've actually finished the section. In fact, we've finished the entire series. But have we finished learning? Of course not. We're never finished learning, right? I'd like to thank you for undergoing this journey with me. And again, you've done such an amazing job. It's been such a pleasure teaching you, and I hope to see you in future courses. Take care, and I'll see you soon.